Hello everybody, welcome to week 2 of our online learning. We're going to be talking about compound probability in this video. Hopefully it doesn't take too long, but let's go ahead and get started. So, there's a few different compound probabilities that you can look for. And we're going to talk about several things, including notation and what compound probability is, and have a few examples of how to find that. So, first thing that we need to talk about is notation. A lot of the times you're going to see something very similar to this. The first letter, P here, stands for find the probability of something. So that's what that means. And then what's in parentheses is going to usually be capital A or capital B. Basically, this just means it's an event. Something is happening and we want to find the probability of that event occurring. Sometimes we might have the variables A, B, C. Other times you might actually have it written out inside those parentheses. So, lots of different things there. Now, there's a couple different things that we can look at. We can have two events, A and B here. And if we have the word or between it, I want to find the probability of event A happening or event B happening. And there are some instances, depending on our situation, depending on our scenario, both events A and B could happen at the same time, or they could happen individually without the other. So this question is asking us to find the probability, and I'm going to shorthand that, of event A occurring or event B occurring or both. And that's if possible. So that's the first thing that we're going to talk about, trying to find the probability of one thing happening or this other. So let's go ahead and start with an example. So we are rolling a 6-sided die, so a D6, and we're going to find a few different probabilities here. So I want to figure out the probability of rolling a 1 or a 2. So event A happening is I roll the die and I get a 1. Cool. Event B is that I roll a 2. And unfortunately, both of these can't happen at the same time with me rolling one 6-sided die. So the or both option does not apply to this case. So every time we find probability, we talked about this in the last video, it's the number of occurrences for this particular problem divided by the possible options. Now for some problems like this, we can probably figure this out in our head, or you can actually write down all the options. So for a 6-sided die, we could roll 1 through 6. Me rolling a 1 or a 2 has 2 options of that happening, and there are 6 total. So that's the probability. Make sure you simplify. So our answer is 1/3, or you can write that as the decimal or the percentage. Now, another question we could have is, what's the probability of us getting an even number or a 3? Actually, yeah, we're going to leave that as a 3. So, looking at this, the first event is us rolling an even number. And we've got a 2, a 4, and a 6 here. Event B occurring is us rolling a 3. So that means there are 4 of those options that satisfy the question, and there are 6 possible outcomes. Make sure you simplify your fraction. And you can either write it as the decimal or the percentage. If you choose the percentage, make sure you have that percent sign. If not, it is going to be wrong. Now, in that last problem, if it wasn't a 3, if I said instead, what's the probability of rolling an even or a 2, then this 3 no longer works. So 2, 4, and 6, what I have circled here, is the event that we roll an even number, and the 2 is happening for both events occurring. So it's just kind of a question of what we look at. Now, there are tons more of examples that can follow this. I was looking for a whole bunch of different questions, and a lot of them dealt with flipping a coin, rolling a 6-sided die or a 20-sided die. And when you look at stuff like that, you have to think of all the possible options. So if you flip 2 coins, your 2 options are heads or tails. Now, before I go further with that, we have to talk about, well, how many options are there for 2 coins being flipped? Well, one option would we flip both coins and lands on heads for both of them. It could work that the first one is heads, the second one is tails. It could work that both tails, and it could work that the first one was tails and the second was opposite. So if I flip 2 coins at once, there are actually 4 different options. So your probability of something would be a number out of 4 possible options, and that just depends on the question. Okay, now moving on to the next part, we want to look at 2 things happening. Not one or the other, but 2 things have to happen for this. So let's look at example 2. And we have a deck of cards. And we are going to pick 2. Now, after we grab the first one, we are going to replace it. So basically what's going to happen is we're going to draw a card, look at it, awesome, put it back, and draw another card. Now, just making sure we all know, in a deck of cards, there are 52 cards. There are 4 suits: hearts, diamonds, clubs, and spades. And every suit has ace, 2 through 10, jack, queen, king. So there are 52 cards total, so make sure you just keep that in mind. So, I want to find the probability that the first card we draw is an ace. We put it back. And then the second card we draw is a king. That would be really, really good for a few card games. So how we do this is we're going to find the probability of each thing happening individually, ace and then king, and then we're just going to multiply those 2 fractions together. So in a deck of cards, there's 52 cards total, so that's going to go in the denominator. And the first card I want to draw is an ace. In the deck, there are 4 aces. After we draw that ace, we put it back, and there are still 52 cards. And in there are 4 kings. So we multiply these together, or in this case I'm going to simplify. 4 divided by 52 simplifies to 1/13, and we're going to multiply both of those. So it's 1 divided by 169. So the probability that you draw an ace and then a king is 1 out of 169. That's not really good odds. Another question we could have is, what's the probability that we draw a heart, then we put it back, and then we draw another heart? So same type of thing, we're going to find the probability of each of those and then multiply them together. So there are 52 cards total. We think, how many hearts are there in the deck? And there are 13 cards with a heart on them. We put it back, and we need to draw our second card, and that'll still be the exact same probability. Now I'm going to simplify these fractions. It's actually 1/4. Multiply them, and that gives us 1/16. So that's actually a pretty good probability that we're going to draw a heart, replace it, and then draw another heart. All right, now example 3, we're still going to have a deck of cards. And we're going to pick 2 without replacing. All right, so same type of thing. We still have 52 cards. So kind of asking the same questions. What's the probability that I draw an ace? I do not replace it. It's out of the deck now. And then I draw a king. So we're going to do the exact same thing. Find the 2 probabilities and then multiply them together. So there are 4 aces out of the 52 cards. So that's the first one. The ace is now gone. How many kings are left? There are 4 kings. Now out of 51 cards, we have now reduced the number of cards in the deck. So that's why that number changes. So we're going to multiply those together. And then simplify that fraction. Make sure you check these numbers in your calculator. And then once again, you can write this as the fraction, the decimal, or the percent. Now, same question here. What's the probability that we draw a heart? We keep it in our hand, and then we draw another heart. Same thing here. There are 13 hearts in the deck of 52 cards. Now, if I drew that first heart, now there's only 12 left. And there's only 51 cards total. So same type of thing here. Multiplying. You get 156 divided by 2,652. And that actually simplifies to 1/17. Fraction, decimal, or percent will be your answer.